So welcome everyone. In this video, we are going to see about number system and base conversions. There are different types of number system: decimal number, binary number, octal number, and hexadecimal number. So in which the binary is the foundation of digital systems. So in which we are using only zeros and ones to represent the data. That is why it is called a base 2 number system. Generally, these number systems used in electronic and digital systems which are very much essential for computing. Other than binary number, there are different types of number system: hexadecimal, octal, and decimal. So decimal is the standard number system that is used in everyday calculations. Other than this, there are different number system: hexadecimal and octal, so which are commonly used to simplify the representation of binary data. So other than this, there are different number system. It is called base 2 number system or duodecimal number systems. These are all very less commonly used and having specific applications in certain fields. So the decimal number system is a base 10 number system. So in which the data, in which the 10 digits are used from 0 to 9. So each digit plays a value is a power of 10, that is 10 power 0, 10 power 2, 10 power 3, like that. Suppose my decimal number is 965. So this LSP bit having the value of 10 power 0. So it has value of 10 power 1. So it has value of 10 power. So 5 into 10 power 0 it is 5, and 6 into 10 power 0 it is 60, and 9 into 10 power 2 that is 900. The total 965. So it is a standard system for everyday counting and calculations. So other binary number system, so it is a base 2 number system. As I already said, it uses only two digit zeros and ones. Each digit plays a value is a power of 2 power 0, 2 power 1, 2 power 2. Binary system is the foundation for data representation in computers and digital electronics. So octal number system, so in which the base is 8. So we have to represent my number is 62. It is octal number. We have to represent base 8, in which the total number of digit used in octal number system is 0 to 7. So each digit plays a value is a power of 8. So the number is 62. So this digit having the value of power 8 power 0, and it has the value of 8 power 1. So like that goes on. It is oftenly used to simplify the representation of binary numbers by grouping them into sets of 3 bits. Hexadecimal number system is a base 16 number system, so in which the digits used is 0 to 9 and A to F. So A represents the number decimal number 10, and B represents the number 11, and C represents number 12, and D represents number 13, E represents 14, and F represents 15. So these decimal number and hexadecimal octal number systems are used to simplify the representation of data. So we know that all the machines, digital system machines, using the binary number to manipulate the data. But why we are going for different number system is used to simplify the number representation. Suppose I want to represent a huge number, consider 65863. It requires more number of bits to represent in binary. Suppose this is a simple number, so we can represent in binary in easy way 1010. It requires only 4 bits, but represent these number it requires more number of bit, and obviously it requires more number of memory. This is why we are going for different number systems in order to reduce the number of bits. So hexadecimal simplifies binary by representing every 4 bits as a one digit. We will see number conversions. So we will see how to convert the decimal number into binary. So if we have here, there is the whole number 10 and fractional part 0.25. Consider this 10, we have to divide the number by 2. So we will be if we are dividing 10 by 2, 5 twos are 10, remainder is 0. So again we can divide this 5 by 2. 2 twos are 4, remainder is 1. Again we can divide this 2 by 2, it is 1, the remainder is 0. Then we have to right from bottom to top 1010. So for the number decimal number 10, corresponding binary is 1010. So consider the fractional part. In order to convert this fractional part, we have to multiply that number by 2. So we will be getting 0.5. Now consider this fractional part and multiply with 2, will be getting 1.0. So if this fractional part is 0, 1 point, that is 1.0, we can stop here. Then we have to write from top to bottom, that is zero point 0.01. So on the whole, we can write 1010.01. That is the decimal equivalent, 10.25 decimal equivalent binary number. So now next we will see binary to decimal number system conversion. So here it is the binary number. So in order to convert this binary number, we have to multiply with power value. So 0 into 2 power 0 and 1 into 2 power 1 and 0 into 2 power 2, 1 into 2 power 3. So in the fractional part, 0 into 2 power minus 1 and 1 into 2 power minus 2. So find the value of these numbers and we will be getting 8 plus 0, 2 plus 0 plus 0 plus 0.25. So the total value is just 10.25, the same value we have got here. Decimal to octal conversion. So here consider this integer part will be having 10. So that divide by, so we have to convert to octal, divide by 8. So 1 8s are 8, remainder is. So the equivalent octal number is 12. Fine, now consider this fractional part 0.25 multiply with 8, so which is equal to 8 into 5 40 and 8 into 2 16 plus 4 20. So the fractional part becomes 0, so we can stop here. So 12.2 base 8. So this is the decimal equivalent, 10.25 equivalent octal number 12.2. So now consider this 12.2 octal number, then we can convert into decimal value. So multiply this 2 into 8 power 0 and 1 into 8 power 1, 1 into 8 power 1, so which is equal to 8, 8 power 0 is 1, so 2 into 8 power 0, the 2 into 1, so sorry, this is 2 and 1 into 8 power 1, which is 8. So total value is 10. So next 2 into 8 power minus 1, so it will become 0.25. So the final value is 10.25. So this is the octal equivalent decimal number 10.25. So next decimal to hexadecimal conversion. So here the given hexadecimal number is A.4. So in hexadecimal, then A represents 10. So this is the equivalent decimal number 10. So 4 we can convert this 4 into 16 power minus 1. So you'll be getting 0.25. So it will become 10.25. So vice versa, we can convert this decimal into hexadecimal number. So next binary to hexadecimal number. So if this is the given binary number, so we can convert this into hexadecimal. So for converting this into hexadecimal, we have to split the given binary number into 4 digits from the LSB. So equivalent 100 equivalent hexadecimal number is actually 1 is in decimal it is 11. So in 11 hexadecimal we have to represent as B. So this is 1101. So this is the 8 plus 4 plus 1, that is 13. 13 equivalent hexadecimal is D. So this is 1100, it is 3. So the answer will become ADB. This is the hexadecimal equivalent, binary equivalent hexadecimal number. So next binary to octal number. So here we have to split the number by 3 digits. three digits. So the equivalent octal number is 101 is 5. So this 5. So 1 equivalent octal number is 7. So 755 base 8. So thank you.